In this you will see what are the different, what do you mean by transaction, then what are the different parts, the life cycle of a transaction, then properties that a transaction must have, then CL schedules, parallel schedules, interleave schedules, those things will see of transaction. So this is your in the last module you have this part, transaction processing. Okay, so what is a transaction? If you are doing a database transaction, that simply means that you are altering or modifying some existing data. Okay, suppose you are drawing some money from your account through the ATM card. Okay, that transaction is also a database transaction, because you are, suppose X amount of money was there in your account. After you retrieve, there is X minus, suppose 5,000 you took out. So X minus 5,000 amount is left. Okay, so all those things are part of database only. So how those things are maintained, and what are the different considerations that you have to make before before and after a transaction is performed. Okay, your account should not be fall below 5,000, because you are taking out only 5,000. It should not be deducted. It should not be deducting 5,000 rupees from your account. Okay, exact that amount you got, you should get. Then also it takes care of any failures. Suppose during the middle of the transaction that you are doing, some power failure or something happens, then what will happen? Whether that money will be deducted from your account or it will be credited back to your account, what will happen? Those things are part of this subject, transaction processing. Okay. In the previous time, when we are maintaining file systems, many facilities were not there, or everything was kind of manual or through application programming. So you have to manually write the amount that you are deducting. Okay, so those were difficult to maintain. But once the database came, the main component was, apart from storage, indexing, etc., apart from good process of storing, you have a better way of dealing with the data. Okay, better way of transacting the data. So uh, if you see that a database can be used at a time by many users. Okay, like, so there is a railway reservation counter you are going to. There are so many persons sitting at the computer. They are all making the tickets. The clerks, okay, the ticket clerks. Suppose there are 7 persons sitting and giving tickets. So all of them are accessing the same database. It is not that for each of them there is different database. They are all accessing to the same database. So how is it possible? There, suppose there is one train where 50 seats are there. Okay. Uh, Suppose exact at T1 time, 2 persons are accessing that there are 50 seats. Each of them are doing two tickets. So at the end of their work, there should be 46 tickets left. Okay. That means what? Every deduction that you are doing, that will take care of other deductions also. It should not happen that 50 at T1 time both are deducting two tickets. So 48 tickets should not be left. There should be 46 tickets left, because two transactions have to be make effective. For one person also two tickets will be deducted. For another person also two tickets will be deducted. Fine. So that part you have to take care of. That means one data is getting accessed by two different users at the same time, but still it is maintaining the regularity. The end result should not be fall below or fall above 46. It should be exactly 46, because two tickets each are being done by two users. Okay, the data is getting accessed at the same time by two different users, or maybe three or four or five n number of users, but the database should be in a consistent state. Here consistent state means, that's an important part. Consistent state means it should not be giving you or showing you wrong result. So that is why the main consideration is whether your database is single user system, because if it is single user system, that is quite easy, because at a time only one user is accessing, and whatever modification he is doing, it is easy to be make effective in the database. But if it is multi-user, you have to maintain synchronous activity, okay, or parallel activity, you can see. That is called interleaved activity also. Um, so that part you have to take care of multi-user system. Then coming about concurrency, concurrency means at a time it can be accessed or it can be worked upon. So interleaved processing is interleaved processing is uh, it's actually a concurrent execution. You will see it as concurrent execution, but that is not exactly parallel. That means two persons are not at a time accessing the database. They will feel that they are accessing the data time at a time, but the database will arrange itself in such a way that one by one it will give access. Suppose one user first updates, it makes 50 tickets to 48 tickets because two tickets is given to him. Then another user is given another two tickets. So 48 minus 2, 46 will be there. That is interleaved. We will see with example. Then parallel is actually parallel. That means concurrently two processes are working upon the database. So that requirement is met by multiple CPUs. So what the definition of transaction? Transaction is nothing but a logical unit of database processing that includes one or more access operation. Okay, that logical unit means entirely your transaction should make the database into a consistent state to another consistent state. Okay, so a transaction will never let the database to have incorrect data. Suppose this thing that at t1 time two persons are accessing to make the ticket. Okay, so it should not happen that after both of them are working, both of them suppose got two seats. Okay, then at the end of the transaction, both of the transaction, the amount of ticket left should be 46, not 48. Fine. So that is a consistent state. 50 to 46 is a consistent state. But if it would have been 48 and two tickets have been each issued to both the persons, then it will be in an inconsistent state. Fine. So consistent state means with correct data. Inconsistent state means with incorrect data. You take the database to incorrect state, that means you are taking the database to an inconsistent state. Similarly, if it is in correct uh, state, that means it is in consistent state. Okay. So in transaction processing, a database is nothing but a collection of data items. We'll see what are data items. Uh, Basic carriers of information. Suppose x equals to 10 you are writing. In that case, x is a data. Okay. So what are the basic operations that you perform in a database? In a transaction, you say that read and write are the two basic operations. Apart from that, there are others also. These are two basic operations, read and write. When you say read item X, that is you are reading a location in memory called X, then storing it into a buffer, then from the buffer you are copying into the variable named X. Similarly, write is writing onto the system or onto the database. Read item X is reading a value from the database. Write means writing onto the database. Okay. Uh, the process includes, if you are trying to read a data using read item X, then it will include these steps. Find the address on the disk block that contains item X, because X is a data location. You have to first find the location on the disk block. Disk block means on the secondary memory or the hard disk where you are storing the database. Okay. Okay. So first you have to find the location, then copy that content from that location onto the buffer. As I said, buffer is a small memory location which is used for holding temporary data. So it will be first kept in buffer, then from the buffer it will be sent to the program variable name X, so that by completing these three steps you say that you are reading a data item X from the database. Similarly, write item X is, you are writing the database, writing the content of X onto the database. So what is the sequence? First you have to find the address in the disk block like the previous one. Before reading, you have to first find the address of the disk block that contains item X. Then similarly here writing, you have to find the address of the disk block, then copy the disk block into a buffer in memory. Okay. Then copy the item from the program variable onto the buffer. Fine. Then that particular memory location can be transferred back from the buffer to the main memory, or sorry, the secondary memory, the database. So writing means you are writing from the program location to the memory location. You are writing something from the program to the memory. This is a basic over screenshot, or you can say a basic type of transaction. There are two transactions being shown, T1 and T2. As I said, the basic operations are read and write. Here you see T1 is reading X, subtracting n amount from X, then writing back the value of X onto the database, because it updated. Suppose you want to update any data, first you have to read it. First you have to read fetch the data from the database, then modify it, then write it back to the database. So for that, first you are reading, okay, this one, then you are modifying, then you are writing. Okay. Then suppose this is the case of the ticket booking. Total there were 500 seats. N is 4. Fine. And 500 minus 4 is 496. That you are updating onto the database. Then this is, you are adding that ticket to someone other's account, say. Or suppose this is a transaction of money transaction. You are deducting 1000 from your account. You are giving that amount to someone else's account. So on his account it will be added. So at the end the total money in the database will be same. Okay, suppose that person has 5,000, this person has 3,000, he gave 1,000. Okay, say this is 5,000, this is 3,000, total they have. So in total it is 8,000 amount of money. Suppose he gave 1,000 to this, so it will become 4,000, this will become 4,000. What's the total amount now? Still 8,000. So this is a consistent state. You are taking the database from one consistent state, that was 5,000, 3,000, combinedly 8,000, to another consistent state, that is 4,000, 4,000. Again, total amount is 8,000. So this is a consistent state. So the consistency of the database is still there. It is still having the correct amount of money, or the correct amount of information or data. Fine. This is also one example where some item is being added onto one account or one variable. So any issue up to now? We go step by step. This is a major concept: database processing, concurrency, locking, then recovery, all are there. There is a last part, means last important part of database concept. Uh, Next to your normalization processes, transaction processing is also one second most important part. So now you know what do you mean by transaction. Transaction is a uh, basic unit of database which performs read, write, and other operations. Okay. So basic operations are mainly read and write. What do you mean by read and what do you mean by write, that we discussed. This is a basic example of your how a transaction looks like. What are the things happens inside a transaction. So no doubt as of now. No problem, anyone? You can write in the chat if not replying. Okay. What is uh, what is why concurrency control is needed? Yeah. So there are some issues when you handle the transactions. There occurs some issue which you have to take care of for a successful transaction. Otherwise, your transaction may be a failure. Okay, because this involves anything. This can involve anything from our account, starting from money to any, starting from money to this ticket booking concepts, and many things are there which comes under the transaction database transaction perspective. So you have to take care of all these issues that may happen. So when you are performing 2 or 3 transactions at a time for any database, you require concurrency control. Okay, that means concurrent access you have to do in a controlled manner. Concurrency means concurrent access. Concurrent means two persons or 3 persons or 4 persons or 5 transactions or something is accessing the same data at the same time at t1 moment of time. 5 transactions are accessing the same data. So say the case of that 50 ticket example. If you allow all of them to access at the same time, all of them want 10 tickets. Okay. Uh, Previously, what happens if you execute the program once, it will deduct. Suppose 50 minus 10, 10 there will be 40 tickets left. Then another program will be executed that will again deduct 10 amount. So one by one you have to proceed like this. At the end of 5 times executing the program, you will get 0 tickets in the ticket booking account. Fine. But if you give access, if you execute the program at a time, all of them will get that yes, I got 10 tickets. But at the end, the total amount of tickets still left will be 50 minus 10, 40. So that is an inconsistent state. Okay. So for giving access concurrently, you require to have uh, pay attention to these problems that may occur. One first thing is lost update problem. The lost update problem occurs when 2 transactions access the same database and have their operations interleaved in a way. that makes the value of some database incorrect. For example, see this one. Here, transaction T1 and T2, there are two transactions. First transaction T1 is reading a data item X from the database, deducting 10 from X. Okay. Then this one comes. This one is flow like this. This is at T1 second, this is T2, this is T3, this is T4. Okay. This is T5 second, this is T6 second. That means this is on the first second. This is second. In the database, this is happening. Third second, this is happening. Fourth, this is happening. Then fifth, sixth, seventh, eighth, ninth. This is interleaved execution. Interleaved means one by one. One by one means one by one unit of transaction. This is a transaction. Inside that there are multiple operations that is being performed. These operations are performed parallelly. Okay. So parallelly means you will see that the users will see that I am accessing X. Suppose T2 is accessing X, trying to add M onto X. T1 is accessing X, trying to deduct N from X and credit that N onto Y account. So both of them are accessing X. So this is a concurrent execution. But you see how um, this may create a problem. The problem is like this. Say X is 50, N is 5. So at the end of this clock cycle, how much will be in X? 50 minus 5, 45. Fine. Then how much this will read? Read item X. This is reading from the database. If you have any doubt, any point of time, you just interrupt at that time. See, when I am saying read item X, the process of steps as you have seen before, it reads the database item from the database itself. So 50 will be he will get from the database. The value here available will be 50. Then suppose n is 5. So x will be 50 minus 5, that is 45. When this is reading, when T2 is reading at third clock cycle, how much value x will see? So how much value T2 will see for x? Because T2 is trying to read that item x. T1 read that item x as 50. It updated 50 minus 5. Here it is x becomes 45. So how much this will be reading? How much value here will be available for T2? Tell me one by one. How much value T2 will be seeing?
45.
बताओ.
45, sir.
Hmm?
45.
Not audible. Can you be a little louder?
45.
45. Anyone else? Hmm? How much value T2 will read for X? Con be quick. There are a lot of things to cover. Or let me ask roll number wise. If you are not replying, there is no meaning of telling all these things. First, this one. Who is this? Tell me the answer.
45, sir.
Huh?
I'm thinking 45.
Not audible. Adesh, what is the answer?
Sir, I'm thinking 45. 45.
45. Aditya?
Aditya Narayan, what will be the answer? Whoever is not replying, no, I will mark absent. Go on. Aditya, you can disconnect. Anamika De,
Sir, I think it's 45.
45. Asha Kumari,
45.
Asha Kumari, what will be the answer?
45, sir.
45. Ashwini Kumar,
Sir, 45.
Badal Sharma,
Sir, 45.
Vishwanath Kumar,
45, sir.
BT18 CH0.
45, sir.
Next, Bulbul,
Uh, yes, sir, 50.
50. Dhanlal Thangi,
I think it's 45.
Dipjoy,
Sir, I guess 45 is the answer.
Haribabu,
So 45, sir.
Linda,
45, sir.
Monica,
45, sir.
Nikhil, Nikhil,
Hello?
Nikhil, हाँ,
Sir, 45, sir.
Rusali,
45 or
Rimo,
50, sir. 45.
Rimo,
45, sir.
Sahil, Sahil, Aditya, you can, if you have network problem, no, you can write in the chat your answer. Okay. Sahil, Sai Prasad,
Sir, 45, sir.
Sajan,
Yes, sir. 45 is the value, sir.
Sunny Kumar, Sunny Kumar, Sunny Kumar has problem every time. Okay, internal marks will be given like that. Ubed,
45, sir.
Jorin Sanga.
45, sir.
Okay, I got only one answer correctly. Bulbul Kumari, it is 50, not 45. How you can say this is 45? I told that if you are reading the data item here, you are modifying it here, and this is reading from the database. It is not reading from T1. It is reading from the database. So have you effected this 45 onto the database? Have you written this data, updated data onto the database yet? No, you are writing it here. This transaction is having these operations. This transaction is having these operations. Whatever this is reading, it is reading from the database. There is no interaction between these two transactions. Fine. Even if they are being performed at the same time or concurrently, they deal with the database. They don't deal with each other. The data does not get passed from one transaction to another. If they are updating it, they need to write it back to the database so that this can read. So there comes a problem where this has deducted 5 from the database. Okay, 45 is here. It reads as 50. Okay, suppose m is 5, it becomes 55. Okay, uh, So what will happen that when this is writing it, this will become how much? How much amount this will write? How much amount T1 will write onto the database?
45.
45 or something else? Writing happens from where? You see the sequence? You see, first you have to search the location X from the memory, okay? Then copy that box onto the buffer, okay? Then copy the program variable from the program location to the buffer. Then type the buffer content to the store or to the memory or to the secondary memory or a hard disk, whatever. So it is always from the buffer. So whenever this one comes, whenever this one is updated, 45 is in the buffer, okay, and whenever this reads 50, this adds 5, 55. 55 will be in the buffer. So when it writes, it will write 55. It will not write 45 because it writes from the buffer. Now again, this will be y. Y is something, suppose y location is being read, then again this will be writing the same updated one, 55. Okay, for buffer content 55. And this one will become suppose 5, whatever you deducted will be added here. So at the end everything will be mixed up. You intended to do that, suppose this is 50, deduct 5 from here and add it onto the y location, and as at a separate case add 5 onto x. But when we mix, this is called lost update, means whatever update this one did is now lost, because 45 should have been there at the end of this point, or at the end of this particular t1, x was supposed to contain 45, y was supposed to contain, suppose y is 10, y was supposed to contain 15. Now x would have been read as 45, then 5 would have been added and it would have become 50. But now everything is kind of mixed. Okay, so whatever update this one performed is now lost, because you introduced this particular operation of the transaction in between these two, between your update and write. Fine. There is another problem also, which is called temporary update problem. You see what is the problem? Suppose T1 is reading the item data from the database, it is updating it, it is writing it. That means at the end of this, x will be 45. Suppose x is 50, it deducts 45 at the end of this in the database, so that's fine. Then you are reading the data item x, that means this will read 45, that's fine. Updated it to suppose 10, that this becomes 55, you are writing it back to the x part, that is also fine. Then you are reading data item y. At this point of time, suppose something happens and transaction T1 fails. The transaction T1 was still there. That means transaction T1 was still continuing. It had still these many operations to perform, but at this point of time the transaction T1 failed. Once a transaction is failing, everything that it performs should be reversed. Suppose you are accessing money from the ATM, okay? You gave 5,000 to be deducted, but there is some problem with the ATM. 5,000 did not come out, but 5,000 is being deducted from your account. What will happen? What normally happens? Have you experienced this type of cases anytime that money is being deducted but money has not come out? What happens?
The bank reverts the money to our account.
Reverse will be done in a second or 2 seconds or something, or some time is required. Maybe it will be reversed in 1 hour, 2 hour, or 1 day, like that. Yes or no? It takes some time to reverse. Immediately it will not be reversed, but it will be reversed. Fine. So what is that reversing? That is called rollback. Rollback of the data. So if amount has been deducted from your account and the money has not been given to you, then anyhow they will return or recredit the amount to your account. So that is the case. Here X was being subtracted by 5. It is being updated, but at some point of time the transaction failed. So whatever deduction was done here, that should be reversed. X should be containing 50, not 45, because the transaction failed. So whatever deduction was there, that will be cancelled. Okay, that is called transaction failure. Due to transaction failure, this become cancelled. But what will happen with this? Because this has read the data item X from the database, because you have written back the item 45, but now it is saying that no, X should be 50, not 45, because the transaction failed. But it has read it as 45. If it failed, it should read it as 50. But by that time this failed, this part of the transaction is already over. So you what to do? This will be writing 45 to the uh, what? No, not 45. Suppose this is 10. So 45 plus 10 is 55. It will be writing back to the database. But this says that no, X should be 50, not 45. You have read it wrong because this transaction already cancelled. So that is called temporary update problem, because this was temporarily updated. It has read it in between and updated the value of X further. But this transaction failed, so everything got cancelled. So can reading of this data, reading of this transaction X value as 45 also got cancelled. This is also not valid. So what will happen is that both the transaction has to be cancelled. Okay, this type of problem occur in your concurrent transaction. Whenever two transactions are occurring concurrently or side by side, then this type of problem may occur. The first one was lost update, second one was temporary update, third one is incorrect summary. Here incorrect summary. Summary means you are generating a summary of some data item. Here summary is initially 0. Suppose this is a variable. You are adding each item and generating the summation. Okay, summation plus a is stored here, summation plus b, summation plus something, then you are summing up x and y, all that thing. Parallelly, concurrently another transaction is performing the same. X is deducted by n, write x, read item y n, means n is being deducted from x and added on to n. That transaction you are performing here. Side by side you are performing a summation operation. So what will happen is that T3 reads x after n is subtracted and reads y before n is subtracted. Yeah. Reads x after n is subtracted, and you see here this transaction was meaning that n will be deducted from x and will be added on to y. Fine. But in this case what you did, here you have deducted n, but that n has not been added yet onto y. In the middle you deducted 5 from x, that's fine, But if it would have been y plus 5, then this would have been a correct summary. But before adding n to y, you are reading the value of y. So the n value is lost from the summary, because here you have deducted by this time, because here suppose this is at t6 location, t6, fine. This is t7, this is t8. So at during t8, x is not having n amount with it. N amount should be going into y account, but till now, till this point of time, it has not been credited onto y account. Still you are reading it. So you are reading a wrong update. You are reading a wrong summary. So whatever summation this will generate, that will be wrong. N amount is not present in this summation because you have deducted from x but not credited back to y. So this type of problem also exists. Incorrect summary problem. Fine. Any doubt up to now? Occupancy control, why it is required? Now, because of these three problems, we require to control the concurrent access of data by 2 or 3 or more number of transactions. The first one is lost update, which says that if you are updating in the middle of another update, then your update will be wrong, because that update was not at all affected. Here x it read from the database, subtracted it, then it read x from the database, added something onto it, then it is writing the value which this one updated, not which t1 updated. So that is a wrong thing. It should have updated its own value, but that will not be possible, because once this is done, this value gets onto the buffer. So this modifies, this writes the value of x plus m, not x minus m. Okay, so that is why this writing is not proper, because this will write again the same thing which this has performed. So this particular update is gone. So this is lost update problem. Similarly, temporary update is suppose this transaction fails, this particular update is also lost, or it will have to be cancelled. So this is lost temporary update. This is incorrect summary. You are generating a summary from a data item source which is not yet complete. Okay, any doubt up to now? No doubts? Fine. Okay, that thing we discussed in the second part, the temporary update problem, that a transaction failed. This transaction failed, because of which the data item that it is updating is also invalid. So why this transaction failed? There are different causes of transaction failure. Okay, the first one is computer failure. Suppose ATM case you take. There is a computer inside that ATM machine or not, or someone is sitting or something. There is a computer inside that. So if during the transaction that computer fails or gets some server some kind of hardware error, so what will happen? The transaction will fail. So that is one type of failure. Then you have transaction or system error also. Suppose your account is not having any money, is having zero, then you are accessing, suppose it is having 100 rupees, you are trying to get 1000 rupees, so it will show error. That is also one type of transaction error. So errors are of different types that may happen with a transaction: a computer error, a transaction error, exception conditions like the what inception account balance come under local error. Exception condition means suppose there is any check applied on that. Suppose you cannot reduce below 1000 amount from your account. Your minimum balance is 1000. So if you are trying to access below that, then it will be an error. That comes under local error. Concurrency control enforcement. So concurrency control, that you will also see there are different methods like locking, etc. If those kind of methods are there, some point of time a transaction will be failing. Are you getting or not? So concurrency control is uh, concurrency control. There are some concurrency control mechanism which are used to let the transactions perform or execute concurrently. So if you try to uh, hamper that concurrency control mechanism, then your error will be shown. The transaction cannot proceed further. Then disk failure, this is a common error or common problem. Because of disk failure or the database will not be accessible, something like that. That will also amount to transaction failure. Physical problem, suppose someone stole the database, the computer is stolen, or because of lightning or something the things are not working, so that is physical problem. So these are different types of transaction errors that you get to see. Any doubt up to now? So book wise, if you define, this is the definition: a transaction is an automatic unit of is an atomic unit of work that is either completed in its entirety or not at all. What do you mean by this is this one. This is, if suppose this is Binu, yeah. This transaction, you are deducting n from x, adding it back onto y. So it should have been completed. This particular transaction should have been completed if n deducted from x would have added successfully onto y. Then you can say that my transaction is complete. So transaction should perform all the operations in such a way that it is completed in its entirety. That means all the operations involved in the transaction are complete. Even if one is left, your transaction will not be complete. So it says a transaction is an atomic unit of work that is either completed in its entirety or not at all. Matlab, in case some operations are left and the transaction is not proceeding further, then everything will be cancelled. Like it was not done at all. That means that x value will be added back onto n value will be added back onto x, so that it will become 50 again. So that is the concept, that any transaction should complete in its entirety or not at all. तो बिल्कुल होगा ही नहीं. Fine. Okay, now let's see what are the different states of a transaction, or how the transaction progresses. Directly you can come to this diagram. It's like a process diagram. In your operating system, you might have remember there is a start, bubble, then ready, waiting, all those things. So here also the transaction is the type, every transaction goes through these stages. First is begin transaction. When it begins, it is in active state. Okay. When it ends, it goes to partially committed state. When it ends means every operation in the transaction are complete, but it is not still fully complete. Okay, that is partially committed or partially complete. When you write commit statement, there is a command called commit. Okay, when you write that particular commit statement, then it will be, the entire thing will be written back onto the Where? The hard disk or the database. Are you listening or I am just saying it? Like
Sir.
last class many of you are only connected, no one replied. Okay. So when a transaction is getting ended, immediately it is not completed. It is partially complete. Why? Because if you remember, there are when you update any database, when you are writing on any data item onto the database, it goes to the buffer first. From the buffer, it goes to the memory. But you say that suppose you are writing write item X. Suppose this particular thing you are writing, this one, write item X. So by writing this, you think that I have written that data item onto the database, but actually not. You have written the data item onto the buffer. From buffer, it will be automatically taken by the memory management module onto the database. So that part is commit. Suppose I am writing a commit statement here. Okay. So immediately this will be written onto the database. There will be no further weightage. There will be no further waiting. But if you don't write commit, operating system will take its own time to update that data onto the database. So thereby commit statements are quite useful. In the previous oracles, suppose Oracle database 11i or 9i something, they were having this statement, the user has to write explicitly. If the user is not writing it, the data will be still there in the buffer. It will not go into the database. But in the later versions, that becomes by default. So even if you don't write commit, that item will be directly updated. But in case of many uh, part where it is required, they write it explicitly. The commit is written explicitly. So when you are saying end transaction, every operation in the transaction is complete, then that comes into partially committed state. When it is commit is written, then it goes to committed state. Suppose before completion of the all the operations in the transaction fails or aborts, it comes to failed state. Okay. Suppose before commit, every operation are being performed correctly, but still some transaction has to abort. Like in this case, you see here, what happened? This failed. As a result, this also has to be negated, or this result also has to be cancelled. This has completed, so this is now in partially committed state, but because this failed, this also has to be rolled back, so this also has to be aborted. So that's why a partially committed transaction also can be aborted and go to failed state. Here you see partial committed, the second one was partially committed but still you abort and it came to failed. The first one was still going on, it has not partially committed, in the middle it aborted and it came into failed state. So after failed, it comes to terminated state. Similarly, from committed, it comes to terminated state. When you are writing or reading anything on the data items inside a transaction, it is still in the active state. So there are 5 different states: active, partially committed, committed, failed, and terminated. Unless and until you are reaching here, the transaction is still very much alive. Okay. So this diagram you have to keep in mind. So these are written here: active state, partially committed state, failed state, terminated state. Here, begin transaction is, it begins the execution of the transaction. Read or write, you know. End transaction also. Commit transaction. Commit transaction is, you are writing that the transaction should be updating the database and complete. Rollback or abort. This signals that the transaction has ended unsuccessfully. so that it can end. Undo or redo. These things we'll see. Recovery. What do you mean by recovery techniques? Hello. There's some interruption. I got disconnected. Am I audible?
Yes, sir.
Yes, sir.
Okay. So as we discussed that whenever a transaction fails, as a result, you have to do so many things that you have to negate whatever you have done. That means the cancellation of all those operations inside a transaction that you have done has to be performed. So for that, there are some commands called undo. Then to redo some of the operations, you have some command called redo. Those things will be used. Okay, before we go on to the uh, recovery part, because how it is recovered, like I said, 5,000, you you are supposed to take out 5,000 from your account, but some error happened and the money deducted from your account, but you did not receive the cash. So what happens is that immediately it does not turn back. It will be uh, reversed. The transaction will be reversed after a period of time. Maybe suppose for some bank it is 1 day or 10 hours or 2 hours or 3 hours, like that. So how they recover, even if you don't give a complaint, automatically that gets recovered. So how it is done? They access the log files. That means they see the details of the transaction, that from where it was accessed, uh, at what time, how much amount it was trying to deduct, how much amount was there in your account, all that thing it takes into account. So those things are written in a log file. So every transaction that you perform, has a log file. Okay, it gets written onto the log file. From there, anyone can see that which transaction occurred under that transaction, how which operations are performed. Those things can be seen. So, what is the structure of the log file? It has entries like this: start transaction T, write item T, this one, read item T, commit T, abort T. These are the 5 things only which gets written onto a transaction. What is this? Start transaction T. Suppose there is a transaction you are performing. Okay, every transaction has an so that is this ID with start transaction. That means this ID contains the transaction ID plus the timestamp. Timestamp means at what time, exact up to second. That means suppose 16 colon 05
Oh,
colon
screen is
5.
not
Yeah,
visible.
it is not visible.
Yes.
I don't know why all if you are silent. I am not able to get. If it's not visible, you tell me from the beginning. This is actually discouraging to take online classes if you not get involved. Okay, we have no option. Uh, yeah, now it's visible.
Yes, sir. Visible.
Okay, these are the 5 things that are there in a transaction log file. So for a transaction, you write the start transaction T. That means this T will be the ID of the transaction along with the timestamp or any other details that this transaction started at this time. Okay, then this entry is for if you are trying to update the database or write anything onto the database, then this will be written write item, transaction name, X is the data item that you are writing, what was the old value, what is the new value. That means suppose you are performing X equals to X minus 9. Okay, so that is under T1. So here it will be T1, this will be X1. Oh, sorry, X, the data item name is X, old value was 50, new value is 45. So from this information, you can get to know that X got updated in the transaction T1, which was previously 50 and now 45. So the amount of updation you get from here. Then if you are accessing the data, suppose you're only reading, then that read entry will also be there in the log file. Which item you read at what time? Suppose you are trying to generate a read the available balance in your account. So at what time you are reading that, that also will be entered. Commit T. Commit T means what time the transaction got completed. Okay, exact time of the completion of the transaction will be known via commit T command or commit T entry. So in the log file, these details will be there with abort T. That means what time the transaction failed. Okay, so that entry will also be present. So records the transaction T has been aborted at what time and which transaction, all those details will be there. So this is the general content of a log file for used in the recovery process of a transaction. Okay, recovery part for the time being I'm skipping because this has some other involvement also. Before after discussing that, we will come to this recovery part. Okay, now these are the concepts of transaction. Every transaction has these basic properties. Every transaction must have these basic properties, that is acid properties. Most of the time in interviews and in GATE syllabus also this question comes, acid rule. Okay, acid rule or let's say acid properties of a transaction or a database. In database management system, every database has this acid. It has to be following this acid rule. Acid means A for atomicity, C for consistency, I stands for isolation, T stands for durability. Okay. Now what is this atomicity? It says a transaction is an atomic unit of processing. It is either performed in its entirety or not performed at all. So uh, atomic unit of processing. What do you mean by atomic unit of processing? Suppose you say that I performed an ATM transaction, or suppose I perform an online payment, online transaction. So the transaction starts from logging into an account, selecting the account to which you want to transfer, entering the amount of money you want to transfer, then your OTP, etc. Then confirmation button pressing, submission, OK, etc. All those things comes under the perspective of a transaction. So the entire process or the entire set of operations comes under one transaction. Similarly, suppose you are going to a ticket booking counter. Okay, starting from giving your name to money to being handed over the ticket, that comes under a transaction. Suppose for online things, if you say that the clerk enters your name, then the seat number or the date which you want to travel, all those things it enters, then a money is paid, OK is marked in the system, then the server or the system prints out a ticket. So that comes as a single unit of transaction. That is a single transaction being performed. That is not multiple transaction. So atomic means the minimum amount of operations required to say that this is a transaction. So every transaction is different. ATM transaction are, suppose if you are saying there are 6 steps, so that is a transaction. The transaction consisted of 6 steps. Suppose for ticket booking, the transaction consisted of 10 steps. So the transaction is of 10 steps. So that is an atomic count. So you have to see that either the transaction is performed in its entirety, that means all the 10 steps are completely performed, then you say that this is a transaction, or not at all. That means not even your name it can store. So that comes as atomicity. Then consistency preservation. That this thing we discussed, that correct execution of the transaction must take the database from one consistent state to another. That means you remember that if you are deducting 5 rupees from one account and you have to add it back to another account, after adding that only your database will be going into a consistent state. But suppose in the middle something happens, the database will be in inconsistent state. So it will be recovered or rollback or something has to be done to make it, to take it to consistent state. So consistent state means in correct state. Whatever amount of money should have been there in Y account, after crediting, that only should be reflected. You cannot reflect less or more amount, otherwise it will be going into inconsistent state. You cannot deduct 2 tickets from 50 and say that I gave 4 tickets, 2 to this, because 2 transactions are performed at the same time. So the database took 2 for this, but reflected only 2 tickets being done, whereas it has given 4 tickets. So that is also an inconsistent state. So you have to take care of this thing, that any transaction or any operation you perform, the database should go from one consistent state to another consistent state. That is consistency preservation. Then isolation. This one is important. Isolation means, like you said, you saw that T1, T2, there are 2 transactions being performed, but whatever value the T1 is writing is not available to T2 because it is reading from database, not from T1. So even if they are being performed parallelly or interleaved wise, still they have no connection in between them. So that is isolation. There may be n number of transactions being occurring in an interleaved manner, but they are in an isolated state or isolated way. Okay. Now final one is durability or permanency. This means once a transaction changes the database and the changes are committed, these changes must never be lost. Yeah. Durability means whenever you commit something onto the database, that means the data goes into the database, that value should be there for the entire part. Unless it is modified further, that value should be present in the database. Suppose from my account I deducted 10,000 and credited it to Y account. Okay. After that, for 5 or 6 or 7 days, I did not perform any transaction. If you access the data of account of both the my and the Y account, then it should show the same amount as it was before 6 days. Yes or no? Or it should be, there should be something less or more. No. Whatever data has been reflected or committed, that should be present for that time, that point of time, until it is further modified. So that is durability. Even if the database fails or something happens, it should be uh, giving you proper data, not incorrect data. Okay. So these are the these are the acid properties for a database, or you can say for transaction also. Any doubt in this four? Because these are normally uh, interview questions. They will ask that, what do you mean by isolation? What happens when three or more transaction occur concurrently? How you ensure isolation between them? How you ensure that there is uh, atomic property being reflected in the transactions? Those things. Okay. Okay. Next thing is about schedules, transaction schedules, or that is called history. Yep. A transaction or a schedule or of n transactions T1, T2 up to Tn is nothing but an ordering of the operations of the transaction, subject to the constant that for each transaction Ti that participate in S, the operation of T1 must appear in the same order in which they occur in T1. Yeah. Note how that operation from other transaction Tj can be interleaved with the operation of Ta. Yeah. Directly come to the example. You see, this is a schedule. Uh, the example is so behind. Yeah. See, this is a schedule. Schedule means there are multiple transactions present. Okay. Here the transactions are performed in an interleaved manner. Interleaved means you are not performing T2 first, then T3 first, then T1 first. You are performing first 3 operations of T2, then 2 operations of T3, then 2 operations of T1, then again 2 operations of T3, 1 operation of T2, 2 operation of T1, 1 operation of T2. So they are all in a zigzag manner. Zigzag manner means one by one. Actually, one by one. This is in T1 second. This is T2. This is T3. At T4 second, you will not find 2 operations are performing at the same time. No. Here at T4 second, only this is performing. No other operations are there. Even if these transactions are active, but only one operation is getting executed. Similarly, at T3 second, only this one is active. This one is executed. At T7, this one is active or executed. Even if all are active, this is executed. So this is called interleaved execution. Okay, these are concurrent, or you can say interleaved execution. So it schedule is collection of this type of transactions where it says that operations of a transaction should be in the same sequence in which they would have occurred as if they are alone. Suppose transaction T2, there is no T1 and T3. How many operations are there for transaction T2? For transaction T2, 1, 2, 3, 4, 5. Okay. Can you write this right item here before reading? No, you cannot write. So this is the sequence of operations that would have performed in T2. First this, then this, then this, then this, then this. Even if it is executed in an interleaved manner with T1 and T3, the same sequence is maintained. This may be a delay between this and this, but this is in the same sequence. So that is the concept of schedule. Okay, you get to see more number of transactions with interleaved execution, but given the constant that the operations in the transaction should be executed in the same sequence as if they would have occurred alone. Yeah. So it is you see the definition. It is an ordering of the operations. Okay, operations means one line. Those lines read item x equals to x minus n. Those are all one operations. Ordering of operations of transactions subject to the constant that for each transaction Ti, maybe T1, T2, T3 that participate in S, the schedule name is S. The operations of T1 must appear in the same order in which they occur in T1. Got? The operations should be in the same order. You cannot reverse or alternate the operations. However, that operations from the other transaction can be interleaved. That means you can zigzag with the operations of other instructions. Okay. Recoverable schedule. Yeah. Okay. What is recoverable schedule? It says that if there is any failure of any transaction in a schedule, it may happen that all the transaction has to be cancelled. That also happens. Okay, or rolled back. But there are methods by which none of the transactions will be rolled back, or the schedule will not be cancelled. Okay, so that is called recoverable schedule. So a schedule S is recoverable if no transaction T in S commits until all transactions T1 that have written an item that T reads have committed. Yeah. This for this an example is required. Wait. Are you seeing the screen?
Yes, sir.
Yes, sir.
Yeah, this is directly I'm taking from the book. See, in your question or your gate or something syllabus, the schedule should be mentioned like this. This is a schedule named SA, where these are the operations R1X, R2X, W1X, R1Y, W2X, W1Y. This means how many transactions are there? Can you say? Under this schedule, how many transactions are there? 2 transactions, 1 and 2. This is the read in transaction 1. This is the write. Sorry, this is the read in transaction 2. This is the write in transaction X. Say, I am writing it. Oh, sorry. Another. Let's do it. Yeah. Suppose this is transaction 1, this is transaction 2. You see here, if you go through this particular part, how a schedule is written. This is a schedule, suppose SA, the name is SA. If this type of things are given, then how do you represent it graphically? First is R1X, that means the first operation is for T1. The first operation is for T1, that is read item X. Okay, R1X means read item X. Then R2X, that means next is for T2. So it will read, sorry, read item X. Okay. Okay. Then next operation is for transaction 1, that is write item. Next operation will be here, write item X. Okay. Then R1Y. So this one will be reading. Fine. You should not write it in the same row because this is one operation. At the same time, at the same clock cycle, no other operations will be performed. This is in the next clock cycle. This is in the next clock cycle. This is in the next clock cycle. So likewise, this will go. The next one will be W2X. That means here W2X. So here it will be writing X, then writing Y. Here it will be writing Y. Okay. So likewise, you have to arrange the schedules. Getting or not? Here you see there is an abort. A1 is abort. That means this schedule is finally aborted. Got? In doubt, now you can represent this in terms of this table or not? Or will there be any problem? If there would have been a R3Y, that means it is a third transaction will be there, which will be reading the data item Y. Okay. Sometimes in some of the books, you will also find there will be not mention of item. It will be written only read X or write X, like that. That is also one of the notations. Okay. So these are some of the examples of the schedules that is being drawn here. You see here. Okay. Here you see this is a schedule named A, where there are two transactions T1 and T2. T1 is performing some set of operations, T2 is performing some set of operations. Here T2 is performing some set of operations, T1 set of operations are here. So here what is meaning is that this is a serial schedule. What do you mean by serial schedule? Serial schedule means the transactions in the schedule are performing their operations in a serialized manner, not in an interleaved manner. Here serial means first all the operations of the transaction T1 are completed. Then the operations of transaction T2 is started. So first T1, then T2. This is a serial schedule. Here similarly, first all the operations of T2 are completed, then T1 operations started. So this serial schedule is of T2 T1. That means first T2 then T1. This is a serial schedule. This is also serial schedule. But this one is interleaved schedule. That means the operations of the transactions are performed in an interleaved manner. Interleaved means one by one or some persons, some persons. So some portions of T1 are performed, then some portions of T2, then some portions of T1, then again some portion of T2, then T1. So this is interleaved manner. This is a interleaved schedule. So you see here, serial schedule A is this T1 followed by T2. First T1, then T2. Serial schedule B, this one serial schedule B, T2 followed by T1. First T2, then T1. Then two non-serial schedules C and D with interleaving of operations. So this is non-serial schedule or also called interleaved schedule. Fine. The problem occurs in interleaved schedule because here you see there may be this lost update, temporary update, or incorrect summary problem occurring in interleaved cases. So whenever you are having this interleaved operations, you have to take extra care. Fine. Okay. Any doubt or issue up to now? No problem. We can continue.
Yes,
Or
sir.
some persons have already left. Oh, okay. What is it associated before? Yeah, this person you can mark. Using this, you can get to know that uh, how the database goes from one consistent state to inconsistent state. That you can see. Say the data item are x and y with value 90 each. N is 3 and M is 2. Okay. So schedule 21.5. If I go into 21.5, yeah, this one. X and Y are both 90. N is 3 and M is 2. N is 3 and M is 2. Now tell me at the end of this one, at the end of this schedule, what will be the value of X and Y? N is 3 and M is 2. At the end of schedule A, what will be the updated value of X and Y? Hmm?
So X 89 and Y would be 93.
X is 90 minus N is 3, that is 87. Yeah. M is 2, yes, 89x. Y is
93.
X is now Y is 93. Yeah, 93. So at the end of this particular schedule, X should be 89 and Y should be 93. Okay. The same thing you try here. What will be the value of X and Y after this schedule finishes? assume that here also it reads 90, not the updated value. This is a separate one, this is a separate one. This reads x as 90, m as 2, n as 3, y as 90. So what will be the result of x and y after this schedule finishes?
'89 and '93.
Sir.
Sir.
Same as schedule A?
Yes, sir.
Same as schedule A or different?
Same, sir.
Same.
Sir, X is 89 and Y would be 93.
Yeah, that means here also you got the same result. So that means whenever you are performing the transactions in a serial manner, you get proper result. Both are giving the same result. So before the transaction started, before this particular operation started or any transaction started, the database was having x as 90 and y as 90. So in total you had 180. After the transaction, after the schedule is over, all the transactions are completed, you still get 87 plus 93, that is 180. So the database is still in consistent state. This is just an example. The total value is same, that doesn't mean that the database is consistent or inconsistent. Just an example that I am assuming that my total value or total amount of money in the system should be same. That's an assumption. Basing on that, the database is in consistent state. Okay, is in proper state. So if you perform T1 T2 or T2 T1, both the result are same, means the serial schedules are fine. They are giving me good or correct result. Just try on any of these two and tell the result. Here it will not be reading 87, it will be reading 90 because this has not been written onto the database yet. Here it will be written and it will be writing this x plus m. How much?
92, 93.
Okay, that means there is some change or incorrect result. The same thing also here, if you see, here what will happen? Here you will get correct result 8793 because this is already writing. So 90 minus okay, anyone got 8793 or something else is coming out or what? Read item x, it is 90 minus n is how much? I forgot. N is 3, so x will be 87 here. 87 plus how much is n? 2, 89. Here it will be 90 plus 3, 93. Same as this. Yes or no? Anyone got or not?
Yes, sir.
Yes, sir.
Yeah. So that means this schedule is giving you correct result as you are obtaining in this two. This is giving you incorrect result. Why? This is also an interleaved schedule. This is also an interleaved schedule. Then where is the problem? It is giving you something. It is giving you something. And
So
how do you?
so
Yeah.
once a variable is read until it's written, that was the problem, sir. So in the first case,
Yeah. So this is
retrieval
facing lost.
not
This is facing the lost update problem. The problem number A. Lost update problem is faced by schedule C, but this is not fetching because this is in proper way. So you are updating it here, directly writing onto the database, so that it reads the proper value, not the temporary value or the incorrect value. So at the end, this schedule gives you proper result. So you have to now choose out of interleave schedule or serial schedule. Which one you will prefer? Because you saw that if you are performing serially, every time the result is correct, be it t1 t2 or t2 t1 or t1 t2 t3 or t2 t3 t1, anything you perform, the result will be always correct. And if you perform interleaved manner, result may be correct or may not be correct. But which one is preferable then?
So interleaved.
Still interleaved.
Yes, sir.
Interleaved is having some error, no? You are getting some error.
So, but CPU is being as it for the Y, we can assign it to we can read and write it, and but in those cases the Y is just hanging till the first one is completed. That is
uh, yeah, so kind of that, but thing is that interleaved is preferred because serial schedule, even if they give correct result, that takes more time. That means some transactions if are longer, suppose say this transaction is having 100 number of operations and this transaction is having only 3, so this transaction has to wait until this completes its entire 100 operations. Even if it is not bothered with these 3 or any of the data item is not involved here, still it has to wait. So there is no point of making it wait if it is not linked with T1. If it is not having any value, that is it is reading from T1. Okay. So in those cases where the serial schedule used to take more time because some of the transactions are having more number of operations or uh, the system performance will be slower. So for that, always preferred is interleaved schedule or non-serial schedule, but with proper arrangement of its operations. You cannot just place the operations like this. You have to place it properly, arrange it properly so that the end result is equivalent to a serial schedule result. That is called serializable schedule. That means this schedule is serializable. Serializable means if I arrange this in serial manner, I will get proper result. Even if this is giving me proper result, that's fine. Means the result of this is equivalent to a serial schedule. So that is why it is called serializable schedule. So you have to write such schedules which are serializable. Okay. So fine. Up to this we'll discuss for today. Next class we'll see that how you will ensure your schedule is serializable schedule. Whether your schedule that you have designed is will give you correct result or not, or suppose this type of schedule you are given, how you can convert this into a serializable schedule. This one is a serializable schedule, how you can convert this to this one. So those things we will see. Fine, let me take the attendance. You go through, all of you go through that Navate book. It is very descriptively written, so easy to understand. These portions are very easy to understand. When you come onto this locking concepts, there is a little bit tricky thing. We'll discuss those things so that it will be clear. But uh, these early transaction part are quite easy, quite interesting, and very easy. So go through them. Okay. Okay then. All of you can disconnect, and we'll take probably day after tomorrow. Tomorrow I don't have I have MTech class. So day after tomorrow we'll take class. Okay. Maybe same 3 to 5, 2 hours, because your I don't know about your exam confirmation is not yet given, whether it will be from which date, etc. But the last date of teaching was 17th November. So the time is very near. You have to complete. This is the main portion actually. If you see the syllabus, uh, 1 minute.
Sir, our exam will be through Viva or like normal like mid-sem exam.
That is still not confirmed. That's why I don't know the date and the method of still
Okay, sir.
not confirmed. You see the syllabus once. Uh, 1 minute. Yeah, these portions we have covered. Okay. Have you seen the syllabus?
Yes, sir.
Majority is this person. We are here now. Concept of transaction property, acid properties. These things we covered today. Concurrency control, locking, error recovery, backups. These things are left. These are pure theories, indexing, etc. That some part also you had read in the data structure part. So that's why I have given that NPTEL link. There are around 3-4 lectures are there. You read it from there. If still time is there, we'll see, or else those are theoretical. So you just go through them. And apart from that, this is one class we'll take query optimization. Then tuple and domain relation calculus. These parts are also left. We'll see. We'll see these parts. Okay. So that's it for today. You can all of you can disconnect.